Alright, and welcome to Two's Complements. Before we get into Two's Complements, I'd like to do a little practice on binary. Let's look at the number 52. 52 in binary can be written as 00110100. Let's look at the number 30. The number 30 in binary can be written as 000111110. If that does not make sense to you, you need to go back and look at the conversion from decimal to binary. What I'm going to do here is add these two numbers. Now a computer cannot do base 10, a computer can only do in binary. So let's add these in binary. 0 plus 0 is 0, 0 plus 1 is 1, 1 plus 1 is 2. I cannot put a 2 down because the computer doesn't know what a 2 is. 2 in binary is 0 carry a 1. 1 plus 1 is 2, 0 carry a 1. 1 plus 1 plus 1 is 3, so put a 1 carry a 1. 1 plus 1 is 2, put a 0 carry a 1, and there is my answer. Now that's in binary. The question is, what is this value in decimal? That's a 2, that's a 16, that's a 64. What's 16 and 64? That's 82. That's my answer. It all works out swell. Now let's talk about where 2's complement is needed. I'm going to rewrite this problem, but instead of addition, we are going to subtract. There's 52. Here is 30. And we are going to subtract. And I'll show you why 2's complement is needed. If I was to subtract this in binary, 0 minus 0 is 0. 0 minus 1 we cannot do, so we must borrow. And if I go up here and borrow, this 1 would go down to a 0, and 2 would come over borrowed. Problem is, a computer cannot understand the value of a 2. And so programmers had to find a way in which subtraction can occur. And what they discovered was, let's simply add the opposite. 52 is 00110100 is 52. How do we make negative 30? That is how 2's complement is used. Here we go on converting 30 into a negative 30. First of all, we start with the number 30. That number was 0001110. That is 30. Of course, I don't want 30. I want negative 30. And the rule is invert, then add 1. Invert, then add 1. What does invert mean? It's quite simple if it's visual. Wherever you see a 0, you put a 1. Wherever you see a 1, you put a 0. There is my digits inverted. And now I add 1. What do I get when I invert and add 1? 1 plus 1 is 0, carry a 1. Here is negative 30 using 2's complements. So I'm going to take this number and transpose it up into my problem. 1, 1, 1, 0, 0, 0, 1, 0. This is 52. This is negative 30. Now let's add. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 1. 0, 1. 1 plus 1 is 2. So we 0 carry a 1. 1 plus 1 is 2. 0 carry a 1. 1 plus 1 is 2. 0 carry a 1. This is my answer? There are basically one major red flag. There are 9 digits. So in 2's complements, it was resolved that if there are 9 digits in your answer, you simply disregard the first digit. If you look at the remaining 8 digits, let's look at the value of the remaining 8 digits. This is worth a 2, that's a 4, that's a 16. 16, a 4, and a 2 make 22. And lo and behold, that is what my answer would be. Notice no subtraction occurred at all. Now comes the tricky part. I'm going to subtract some numbers. Here's my first one. Let's do 20 minus 30. Obviously, you know what the answer is. The answer is negative 10. Let us see how the computer has to do subtractions. The 20 isn't the problem. So how do you write 20 in binary? Let's see. I do not need a 128. I do not need a 64 or a 32. But I do need a 16, no 8, a 4, no 2, and no 1s. That is a 4. That is a 16. That makes 20. Well, what about minus 30? Well, I picked minus 30 simply because I make this plus negative 30. And you'll notice it's the same number from before. So I'm just going to take that number from before and write it down. If in doubt, if you remember what 30 is, here's 30. 0, 0, 0, 1, 1, 1, 1, 0. To make negative 30, I'm going to invert, add 1, and here's my negative 30. So I'm going to take negative 30 and transpose it into my problem up above. 1, 1, 1, 0, 0, 0, 1, 0. This is 20. This is negative 30. Let us add. Here we go. 0, 1, 1, 0, 1, 1, 1, 1. 20 plus negative 30 is negative 10, but this is the answer that's showing up. This does not look like negative 10. In 2's complements, the next thing we've got to recognize in 2's complement is that if your answer of 8 digits begins with a 1, your answer is negative. So this does not look like negative 10 the way it looks. However, that is telling me my answer is negative. Of course, you should ask yourself then, negative what? Well, if I know my answer is negative, which I do, I'm going to convert it into human world and tell me what that value is. How do I convert a negative number into a number that I can understand? In 2's complement, it is always, always, always invert, add 1. I know this is a negative number. How do I convert it into a value I can understand? Invert, add 1. So I'm going to rewrite that number, 1111, 0110. I'm going to invert. When I invert, I get 1001. And now I'm going to add 1. 1 plus 1 is 0. Carry a 1. That's a 1. 0, 1, 0, 0, 0, 0. This, if you notice, equals 10. My answer, though, is not 10. It's negative 10. As a programmer, we have to notice that if I have a negative number, I would put a negative symbol on the screen. I would then invert, add 1 to get the value of the negative number 10. So this is 10. This is negative 10, which the answer is. But I do hope this helps. If you have more questions, obviously let me know, and good luck.